Now, one of the nice properties that is possessed by the normal distribution um, is the so-called empirical rule. Okay, and what it basically says is that for a normal random variable, uh, 68% of observations will lie within one standard deviation of the mean. 95% of observations will lie within two standard deviations of the mean, and 99.7% of observations will lie within three standard deviations of the mean. Okay? And so what I've drawn here is I've drawn a normal distribution. As you can see, the mean is located dead center, as it must. And what we can see is that if I go 1 sigma to the left and 1 sigma to the right, the area under that curve, okay, would be 0.68. That's why it's 68% of the observations, okay? Again, let me recap what that means. The area under the the area under the normal curve, any normal curve, when you go 1 sigma to the left and 1 sigma to the right, that strip, that area under the curve is 0.68. So 68% of observations we expect to lie within 1 sigma from the mean. Okay? Now, if I take the strip that starts from the mean minus 2 sigma, if I take this strip and I paint underneath all the way until I get the boundary where the mean is plus 2 sigma, okay, where the boundary is the mean plus 2 sigma, then that will have area 95, well, 0.95. And so it corresponds to 95% of observations. Likewise, if I start at mu minus 3 sigma, the mean minus 3 standard deviations, and I end with the mean plus 3 standard deviations, the area under the curve will be approximately 0.997, and that's why I have 99.7% of observations. Now, the exciting thing about this is that we're finally going to be able to use the empirical rule to solve some of the most basic probability related problems dealing with normal distributions. We'll be able to use the empirical rule to do that, and we're going to do some of those right now in a brief moment. Another thing I want you to know is this. What I want you to notice is that if 99.7% of the observations should lie within 3 standard deviations, you can see right away that only 0.3% lie outside on this side and outside on the other side. So in other words, if you're sampling, if you have a sample from a normal distribution, if you take like some value from a normal distribution, you're going to get a value in here almost all the time, okay? Because you have 99.7% of the possibilities in here, okay? So there's very little chance to be outside of it, okay? And so even though you can calculate the probability that something is way out here, or some range is going to be way out here, the probability of that will be very low, because most of the distribution is located right here, as you can see from these numbers. Okay. Anyway, that's just a minor observation. The most important thing is this part here. Okay, that 68% of observations lie within 1 sigma, 95% within 2 sigma, and 99.7 within 3 sigma, and what's also nice is that it's going to allow us to do some of our first calculations. Okay, these will be the simpler calculations to do. And so without further ado, let's do that. Thank you.